So today we're going to introduce a new topic called radians. It is believed that in an ancient Babylonian empire, the calendar year lasted only 360 days. Since 360 was one full cycle in a year, it's from this empire that the 360 degrees circle was born. A degree then was defined as 1/360th of a circle. And today now we're going to introduce a new term, radian. Radian, in extremely simple terms, means how does it compare to the radius? Keep that in mind. We're comparing an object to the radius. So since we're talking about a circle and a radius, let's start with a circle. All circles have a center. If I make an angle using the center of a circle, it's called a central angle. And I'm talking about the angle right in here, where the vertex of the angle is the center of the circle. A central angle, we're going to name an unknown angle, theta. That's this symbol right here. It's called theta. I use theta for an angle like I use x for a variable. Of course, we have a radius. You already know about that. Now, this part of the circle we're going to call an arc. Okay? An arc is simply part of a circle. A circle also has circumference, of course. Circumference is defined as 2 pi r, where r is our radius. So, as we go on with circumference really quickly, circumference, when I divide it by the radius, is 2 pi. Remember, circumference talks about the distance around the outside of the circle. If I divide my circumference by radius, that gives me 2 pi. 2 pi is really significant when it comes to radians. This is telling me that the circumference is 2 pi radiuses long, and I know that's completely bad grammar, but just to introduce this, that's how I'm going to say it. 2 times pi is 6.283, and this goes on forever, of course. That means that my circumference is just over 6.2 or almost 6.3 radiuses long. Since it's 2 pi radiuses long, I can change that horrible English word into radians. The circumference is 2 pi radians long, or nearly 6.3 radians. We can say any circle is 2 pi radians around, by the way. So from there, we're going to learn how to switch between degrees and radians. We need to understand the difference between the two because they're not exactly the same thing. So here's our circle. The central angle, theta, is measured in degrees. So degrees measures an angle. Its subtended arc, okay, this arc is called subtended because it's the part of the circle that gets cut off by that angle, right? I have my central angle. If I span those two sides out, it actually cuts off this portion of my circle, and that's a subtended arc. The length of this arc, S, is measured in radians. So when I'm talking degrees, I'm talking about the measure of the angle itself. When I'm talking radians, I'm talking about the length of the arc that's created from that angle. So a full rotation of a circle, on the inside of the circle surrounding the center, I have 360 degrees of rotation, 360 degrees of angle inside the circle. On the outside of the circle, I have 2 pi radians. So full rotation is 360 degrees or 2 pi radians, but they're not exactly measuring the same thing. I need to make that really clear. But loosely, and I say very loosely, we can kind of say that 360 degrees is the same as 2 pi. I can cut that down, right? If I divide both sides by 2, 180 degrees, which is a semicircle or half circle, is equal to pi radians. So in that case, let's learn to switch between the two. If I'm given a measurement in degrees, okay, since 360 degrees is a full circle and so is 2 pi, I'm going to use that to my advantage in switching between degrees and radians. 50 degrees means 50 degrees out of a full 360 degree rotation. So I have the fraction 50 out of 360. If I multiply that by 2 pi, look what happens. 50 times 2 pi gives me 100 pi over 360. If I reduce that fraction, I get 5 pi over 18 radians. So 50 degrees is the same as 5 pi over 18 radians. Most often you will see radians written in terms of pi, which means that there will be a pi in your radian measure. Sometimes though, you'll change that to a decimal, okay? It's not going to be an exact decimal because this is going to be an irrational number that's going to go on for a very long time. So as a general rule with radians, we round to 4 decimal places. So if I multiply in my calculator 5 times pi and then divide by 18, and I round to 4 decimal places, I get 0.8727, and technically that's the number of radians I have. So 50 degrees, a 50 degree angle creates an arc that's 0.8727 radiuses long, or radii long. Notice that we multiplied by 2 pi over 360. Really, that's the fraction that we use to change degrees to radians. I'm going to reduce that fraction though to pi over 180. If I divide both of them by 2, I get pi over 180. This is the fraction that I'm going to use to help me go from degrees to radians. So let's go through a couple quick examples. Let's change 90 degrees into its radian measure. If I multiply that by pi over 180, I can reduce 90 over 180 is the same as 1/2. And when I multiply that by pi, I get pi over 2 radians. If I change that to a decimal, if I do pi divided by 2, I get about 1.5708 radians. So it's about 1.5 as long as the radius is. 200 degrees, if I want to change that to radians, again, I multiply by pi over 180. Reduce my fraction. You can multiply and then reduce. Not a big deal. You're going to get the same answer either way. But I'm going to get 10 pi over 9 radians, which then if I do 10 times pi and divide that by 9, I get about 3.4907 radians. We can also go from radians to degrees. So if I have, say, 2 pi over 3 radians, I'm just going to use that same fraction I used before and flip it upside down since I'm trying to go in reverse, right? So 360 is about the same as 2 pi radians. I can reduce the 2 pi right out of the picture, and I'm going to be left with the fraction 360 over 3, which is the same as 120 degrees. This is like your conversions in chemistry class where you had to multiply by an equivalent fraction just for the sole purpose of being able to cancel something out. So going from radians to degrees, I'm going to flip my fraction upside down so that I get 360 over 2 pi. If I reduce that fraction, I get 180 over pi. 180 over pi is what I'm going to use to change every radian measure to degrees. So let's try. Let's start with 3 pi over 4. If I multiply that by 180 over pi and reduce, I'm going to get 3 times 45, which is 135 degrees. When I reduce, remember the pi over pi reduce, but so does the 180 over 4. 180 divided by 4 gives me 45. That's why I have 3 times 45 left over. You can simply multiply straight across the numerator and denominator before you reduce. You're still going to end up with 135 degrees. Next, let's convert pi over 3 into degrees. I multiply by 180 over pi. The pi over pi reduces themselves right out of the picture because pi over pi is just 1. 180 over 3 reduces to 60. And I'm only left with a 60, so pi over 3 radians is the same as a 60-degree angle. Given the right information,
Sage, Rug, if you're still in the building.
Sorry about the announcement. Given the right information, we can find measures in degrees and radians. So here I have a circle. I have the center of that circle. I have a central angle coming from point B, which is the center. I'm going to name the end points of my arc, right? A to C around the edge of my circle is an arc. We're going to call that arc AC with central angle B. Our angle, our central angle, remember we call theta. And arc AC, notice the notation here. A and C are the two endpoints of my arc. And I use a little arc symbol to indicate that it's an arc, not a line or a segment or anything else. So arc AC, I'm going to say, is 19 inches from end to end. My radius, we're going to say, is 7 inches. To find the measure of theta in radians, okay, remember that our arc measure, we want to find out how many radians that is, which means how many times the radius is 19. This is a pretty simple process. It's simply the arc measure, right, the subtended arc, divided by the radius measure. That's going to give me the number of radians. So 19 divided by 7 is about 2.7143 radians. Arc measure divided by the radius. If I want to find that measure in degrees, that will tell me the measurement of the central angle. Remember, I can take that number and times it by 180 over pi. And that's about 155.5 degrees. So this 19-inch arc in radians is about 2.7143. And that makes this central angle theta about 155.5 degrees. To start the unit circle, we're not going to go very far with this today. I think we better leave that for another time. The unit circle is called a unit circle because its radius is always 1 unit, whether that be 1 inch, 1 foot, 1 centimeter, 1 meter. It's always going to have a radius of 1. Keep that in mind. We'll call this to be continued. Make sure you write down any questions that you have. And don't forget to take the quiz and bring your notes to class. Have a great day, and I'll see you later.